Following on from our previous two videos, we've seen that in order for us to integrate this, we would have to somehow get from here to here. So we developed a way of working out A and B. We developed a method of working out A and B. Well, in order for our method to work, these two conditions must be satisfied. These two conditions must be satisfied. So in general, when you're trying to integrate one polynomial over another polynomial, our method will only work if Q of x must have distinct linear factors. Now distinct means, going back up to here, distinct means, well, if you look at this here, distinct means that all the factors must be different. So you can't have another x minus 1 here, because here you've got a factor here, and then these two are the same. They all have to be distinct. So you could have another one like this. Now they're distinct. They're all different, because -1, +2, -5, they're all distinct. Okay, and hang on. Q of x must have distinct linear factors. Well, linear in this case means all the factors here must be linear. So you can't have a factor like this, x squared plus 7, because here this is not a linear. Linear is when the power of x is 1. So you can't have this as a factor, x squared plus 7x minus 3, say. This is not a linear factor. This is a linear factor. This is a linear factor. When x is to the power of 1 is a linear factor. Okay, so in order for our method to work, we need them to have distinct. We need Q of x must have distinct linear factors. So let me give you this example here. You see, all the factors here, they're all distinct. They're all distinct, and they're all linear as well. So this condition here is satisfied. Okay. So in general, if you have something like this, you can actually break it up like this. And then the other condition is that the degree of P of x must be less than the degree of Q of x. So if you go back up here, if you look at this here, the degree here is 1. The degree is the highest power of x. So in this case it's 1. And then if you look here, the degree here, the highest power of x is actually 2. So the degree here is 2. The degree up here is 1. The condition is that the degree at the top must be less than the degree at the bottom. Okay, so if you look at this, so this condition here, the degree of P of x, the degree here must be less than this degree here. Okay, so looking at this example, if you look at this here, the degree of this is the highest power of x. In this case, is 2. So the degree of this whole thing here is 2. Now, if you look at this here, the highest power of x is really x times x times x. The highest power of x here is x to the power of 3. So the degree down here is 3. The degree up here is 2. So you can see that the degree at the top is less than the degree at the bottom. So this condition is satisfied. Okay.